Hello class, in this video we're going to take a look at an example of running through the whole four-step process of the inference procedure we call a one sample t-test. Now that is used in a scenario when we want to test against a hypothetical population mean by collecting a random sample and seeing if that sample is far enough away from the hypothetical value. So let's take a look at an example of that. And let me pull up the screen I'm looking to share here. All right, is that up? Yeah, there we go. All right, so in this example, let's say an amusement park has instituted a new procedure with the hopes of reducing the mean wait time for that park's signature roller coaster, the Enforcer. With the old procedures, the mean wait time for that roller coaster was 48 minutes, and the park selects a random sample of 10 patrons to measure their wait time for the Enforcer. For those 10 patrons, they find a mean wait time of 44.2 minutes and a standard deviation of 9.1 minutes. The box plot here shows the distribution of their wait times. And the question is there statistical evidence that their new procedure has decreased the mean wait time for the Enforcer? And we're going to run an appropriate significance test at the alpha 0.05 level to tell if we have enough evidence that their mean wait time has decreased. Now, let's pull the important information out of this problem. Is we need to know what's the hypothetical mean we're testing against. Well, that would be the mean wait time that they used to have, 48 minutes. We also need to know what's our sample size. Well, that would be the 10 patrons that they selected at random. We also need to know their sample mean and standard deviation, and that would be 44.2 minutes and the standard deviation 9.1 minutes. So those are the really important pieces of information that we'll need to pull in order to run this test. So in step one, what we'll do is we have to state our parameter of interest and state our null hypothesis and alternate hypothesis. So in this case, we have a population mean because we're looking at an average wait time. It's quantitative, it has units. So that all points to the fact that we're looking at a mean. So mu here would be the true mean wait time. And that's going to be in minutes for the Enforcer. Our null hypothesis is the hypothetical wait time that we're testing against. And in this test, we won't change our minds about the 48-minute wait time unless there's evidence or reason to do so. So our null hypothesis would be that mu equals 48 minutes. The alternate hypothesis is what we're trying to find evidence for, that our now true mean wait time is somehow different from 48 minutes. And in the problem, it explained that we're looking for a decrease in that time. So mu is less than 48 minutes will be our alternate hypothesis. Then in step two, what we'll do is explain what's the name of the procedure we're going to run and show that all the conditions are met to run that type of a procedure. So we are running a test for one single population mean, and we don't know sigma, the population standard deviation. And those things all point to the fact that we're now going to be running a one sample t-test. So we will run a one sample t-test. Make sure you give that full name, one sample t-test. And we're going to run that at the alpha 0.05 level. Make sure to look through the problem for that alpha level, and if it's not given, 0.05 is usually a good one to stick to. All right, three conditions need to be met in order to run a one sample t-test. Number one is that we need a simple random sample. And the problem stated that we pick 10 patrons at random from the population, so that one's met. The normal condition could be met in three different ways. The easiest way, number one, is that the population is already stated to be normal. But that's not the case here. Number two, if our sample size is at least 30, we can reference the central limit theorem, and that shows our sampling distribution is approximately normal. But our sample size is only 10. So the last thing we can do is take a look at a graph of that data, and if it's approximately symmetric without any outliers, then we're good to go on the normal curve check. And so a box plot was given in the problem, and that was roughly symmetric, and it didn't have any outliers. So we'll just explain here that the box plot was roughly symmetric and that there were no outliers. And the third condition that we need is independence in our sample, and that we would need to have the population to be at least 10 times the sample size. Since our sample is 10, we would have to assume that there's more than 100 patrons at this amusement park, and that seems pretty reasonable to assume. So our three conditions are all met. We're good to go on running the one sample t test. Now in step 3, we get to the calculation, and you need two things in this step. You need to calculate, number 1, your test statistic or t-score, and number 2, your p-value. So first things first, the test statistic, the calculation for that in a one sample t-test is x bar minus mu over s over square root n. Well, our sample mean x bar was 44.2 minutes, minus mu from the null hypothesis, 48 minutes, over the sample standard deviation, s, 9.1, over the square root of the sample size, 10. Run that through on a calculator, you're going to get a test statistic of negative 1.32. From that test statistic, now we need to calculate a p-value so that we can compare to our alpha level to see if we have enough evidence or not enough evidence to reject the null hypothesis. Now, there's a couple different ways that you can do that. So let me pull up the table, and I'll show you how to find that on table C. Let's see. It's table C. All right, so on this table, what you're going to look for is on the left side, you have to find your degrees of freedom, which is your sample size minus 1. We had a sample of 10, which means then we have 9 degrees of freedom. So what we're going to do is look at the row of 9 degrees of freedom and follow that to the right until we find a window that our test statistic falls into. Now, because they're all positive on the table, we're going to have to use the absolute value, 1.32. So we're going to follow that row 9 to the right until we find a window that 1.32 falls into. So we haven't gotten there yet, There we go, 1.10 to 1.383, our test statistic of 1.32 falls right into that window. So since we know it's between those two values, we'll follow those up to the top, and it'll give us a window that the p-value falls into. And that would be anywhere from 0.15 to 0.10. Or flip it around so smallest is first, 0.10 to 0.15. So on the table, we can see that the p-value is between 0.10 and 0.15. And even though we don't have it exactly, that's still enough information to reject or fail to reject the null hypothesis. Now, the second way we could do this would be on the Inspire. So let me pull up the Inspire. All right, so on the Inspire, you can go to a calculator page. So we'll go open up a new calculator page. And since we know the test statistic or t-score, because it's a t-value, we're going to go to menu, 6 for statistics, 5 for distributions, and then 5 for t-CDF. Now our p-value, because our null or alternate hypothesis is that mu is less than, our p-value is going to be on the left side of that distribution. So our lower bound is negative infinity. It's going to stop at our upper bound at negative 1.32. So we'll type in here negative 1.32. Our degrees of freedom, since our sample was 10, degrees of freedom will be 9. And hit OK. And 0.110, if we round that. 0.110, there's our p-value. And just as we suspected, it fit right into that window between 0.10 and 0.15. Now that we have our test statistic and our p-value, what we'll do is, in step 4, interpret that meaning. So now we'll compare this p-value to our alpha level, 0.05. And because it's greater than 0.05, that means we don't have enough evidence that the mean wait time has decreased. So we will fail to reject the null hypothesis. Always start it out with a comparison of your p-value to your alpha level. So since p is greater than 0.05, and if you want to be really explicit about it, you can say 0.110 is greater than 0.05. We fail to reject the null hypothesis. Remember, never accept. Never say you're going to accept the null. That's bad right there. Don't say we accept the null. We fail to reject the null. There is not evidence that the true mean wait time for the enforcer is less than 48 minutes. The p-value being more than 0.05 shows that this sample mean is kind of likely to occur just by random chance if the true mean wait time is 48 minutes. And so that's the reason why we're not having enough evidence. It's likely this just occurred to chance due to random sampling variation. All right, one last thing I'll show you is if you have an Inspire and want to use it to take care of step 3, then there's a couple of quick buttons to press to make that happen. So let me bring up the Inspire again. All right, so if you go into a calculator page and bring up menu, 6 for statistics, 7 for stat tests, you'll notice that the name one sample t-test doesn't show up in here, and that's because they just called a plain old t-test. So menu 672 will bring up a t-test. Now, we would pick data if we had a list of all the individual wait times for those 10 people, but we don't. We have the stats or the summary statistics for those 10 people. So we're going to pick stats there. mu0, type in the mean from the null hypothesis, 48. X bar, that's the mean of the sample, 44.2 minutes. Standard deviation for the sample is 9.1 minutes. Our sample size was 10. And the alternate hypothesis is going to default to not equals. So make sure you change that to mu is less than mu0. All right, we've got all the summary statistics we need. So hit OK. It's going to give you your t-score of negative 1.32, just like we had calculated, with a p-value of 0.1096. We'll round that up to 0.110. If you're doing it this way, I would recommend just copy down everything it tells you. T equals negative 1.32. P-val equals 0.110. DF equals 9. And all that good stuff. So that's how you can take care of step 3 using the Inspire. So a quick recap of what you should be able to do from this video are the 4 steps involved with a one sample t-test. State your parameter of interest, your mean, your null and alternate hypothesis. Step 2, write out your plan. We're going to run a one sample t-test at the alpha 0.05 level. Check your 3 conditions: random sample, approximately normal, and independence if you're sampling without replacement. Step 3, calculate your t-score, test statistic, and p-value. Doesn't matter if you do it by hand or on the Inspire. And step 4, compare your p-value to your alpha level to either fail to reject the null or reject the null, and then give the context about what that means. Remember, if you fail to reject the null, that means you do not have evidence for your to support your alternate. If you reject the null, that's because you do have evidence to support your alternate. So make sure those two always go together. Fail to reject, not enough evidence. Reject, significant evidence.